Another problem from Leetcode, question number 283, and which is the move zeros. Read the problem statement and try to understand. Given an integer array norms, then move all zeros to the end of it. So if we are having an array, then we have to, it is saying move all the zeros into the end while maintaining the relative order of the non-zero element. Other than the zeros, elements should maintain their orders as it is. Here also it is saying you must do this in place, no extra array, without making copy of the array. Understand from this example, it is saying, or it is given 0 1 0 3 0 1 0 3 12. We have to move the 0 element to the end of the array. The output should be like this, right? Notice something, the order 1 3 12 1 3 12, the order should be same and the end of the array should be with zeros. The checklist for this question for the two pointer are in place, then it is saying keep non-zero element, ignore the zeros. This indicates us to use the two pointer approach. Did you remember something for the last question? It was saying to remove the elements from a given array. The last time we have done like this, one array is given and value will be given. So we have to remove these values and keeping all the elements which are not equal to the value to the front. The question we are working here is also sound very similar. There it was giving an value, but here it is giving as a 0 and we have to keep in the end. Last time for the loops how we just ignore these values, same thing we are going to do here. You will ignore the zeros and we will put all the non-zero element to the front. So later on we can put all the zeros in the end. It will be more easy. Instead of putting the zeros in the end, first we will keep all the non-zeros element to the front. Let's take an example and we will try run and we will try to understand how we are going to solve this question. From this question, I think you already get it. So this is going to use the slow and fast pointer. Slow and fast pointer. We have to declare two pointers out there. Slow and fast pointer in the starting. Let's declare slow and fast. Both are starting from 0. Zeroth index. Why zeroth index means the first value also can be 0, right? So we have to skip that. So main motive of this solution is we are going to skip 0 and keep all non-zero element in the front and remaining element we will keep 0, right? So first pointer is going to move from 0 to n, the size of array. So here we will get two cases. Case number 1, element 0. Case number 2, element non-zero. We have already discussed we are going to skip the 0 element. So here if array of first equal to 0, we will just skip it. We are not going to perform any operation. So first plus plus. Else when the first pointer not equal to 0, when it is a non-zero element, we are going to do the same operation. We will put the first pointer element to the slow pointer. Array of slow will become array of fast, and we are going to increase the, also we will increase the fast pointer, right? Let's do dry run for this much logic. We'll see what the array became. Let's do the dry run for this array. So slow pointer, fast pointer both are in same position. What we'll do? we are going to check whether the first pointer element is 0 or not, right? The first pointer is 4 right now. Array of first equal to 4. We'll compare 4 equal to 0. So it's false because it is not equal to 0. It is not equal to 0. When it is not equal to 0, what are the things we have to do? We have to give the first pointer element to the slope pointer. As you can see, the first pointer and slope pointer both are in the same place, so the element will not get changed, right? But we have to do the operation. So the array will be this only, but other thing will happen. Like slope pointer will move and fast pointer also move. Slope pointer will move. Let's move the slow and fast pointer. Both will be here, slow and fast, because both are increasing when there is a non-zero element. Now we'll check array of f. Array of f means now which position? This is 0, 1, 2, 3, 4, 5. Array of 1. Array of 1 equal to 0. 0 equal to 0. It is true. When it is true, we are just keeping that element. Keeping that element means we are not doing any operation. We are just moving the first pointer. So we'll move the first pointer f plus plus, right? F plus plus means here the s will be there, but first pointer will move here. Now again array of 2. Array of 2 equal to 4, which is not equal to 0. If it is not equal to 0, we'll give the first pointer element to the slope pointer, right? This 5 will come to here, right? So we'll do the same. 5 will come to here. 5. But here the 5 will still there. Now we are moving the slope pointer also, right? So the first pointer, when first pointer will move one step, it will come to here, and when the slope pointer will move, it will come to here. Now first pointer is 0 element, so again only the first pointer will move. This condition, first pointer will move. First pointer will move means will be here. Again first pointer is 0, so again we will move the first pointer. But now the first pointer is having a non-zero element. When it is non-zero element, we are going to put the first pointer element to the slope pointer position. So what it will become? The 5 will become 2. And we will move the first pointer and slope pointer. So the slope pointer will come to here. The first pointer goes beyond the array. When it goes beyond the array, we used to stop. We have written this condition 0 to n minus 1. This will be n minus 1. 0 to n minus 1. Now the loop has ended. When the loop has ended, we get this array. This is our array. What we get after this loop. The desired output is this one. Compare the element 4, 4, 5, 5, 2, 2. So it's maintain the order of how it was before. But only one thing remaining, other than non-zero element should be 0. Here it's 0, but in our case it is not 0. Now notice something. We are S here. S means where, from where we are going to have the 0 elements to the end, right? What we'll do, we'll start a new loop while S, from S to where? N minus 1. What we'll do, we'll put all the zeros there. Array of S will be 0. In the end of the loop, every element will become 0. Now you see this array and this array, both are same, and we got our result. Let's jump into the Java solution. First try it by yourself because this is already I have explained and also very similar to the previous question. This is our function for this solution. Right now we will declare the slope pointer and fast pointer. It is slow equal to 0, fast equal to 0. Now we will start the first loop. First loop is for what? To bring all the element. Which element? Non-zero element to the front. Okay. You'll start the loop for, can use while also. F less than array dot length, then F plus plus. No matter what, we are going to increase the F, right, with the both the condition. You can see here. In this condition, when the element is not equal to 0 and when the element is equal to 0, both the cases we are incrementing the fast pointer. That's why for a optimized code, we can write a for loop here. Fast is going to improve. And you can see here, fast is increasing for when it is a 0 element. When it's non-zero element, only then we are doing some task out there. So here we'll write the condition for that. If array of f not equal to 0. You can write the same code I have written before, but this is just optimizing the code. Not equal to 0. What we are doing? Array of slow equal to array of fast, and we are incrementing the slope pointer. We don't have to write the f plus plus here because no matter what, it will be going to the next index, right? This, so the first loop has been ended here, and the second loop will write to make all the zeros at end, right? So this here we'll just write the while condition, while the slope pointer, right? We have discussed here. Here you can see our slope pointer is here. So while s is less than array dot length, what we are going to do? Array of slow equal to 0. That's all. This is our solution for this question. Here the time complexity will be, for this loop we go of n because we are not iterating any elements twice, and here also we go of n. If we merge both, then also it will become big O of n, and the space complexity will be big O of 1. We didn't use any extra spaces. You can merge these two things also in one loop. Try to think about that and how we can optimize more this code. If you get it, then you can try to solve with that approach also.